Okay, example 2 is a little more challenging because it requires us to have a full understanding of what the definitions of the different enthalpy changes are. So if we start by having a look at that, we're looking at calculating the electron affinity of chlorine, and we've been given lots of information. Now the key thing is there, they've told us that we've got the standard enthalpy of formation of potassium chloride. So the first thing I'm going to do is write out the equation for that. So standard enthalpy of formation would be potassium in its standard state plus chlorine in its standard state to make KCl in its standard state. Again, remembering that enthalpy of formation means we make 1 mole, so we're going to need half a chlorine. Now, before even thinking about the numbers that they've given me there, I'm going to just take some time to write out my key equations. So if I look at this, the first thing I'm going to have to do is again take the potassium as a solid and change it to potassium as a gas. Now that is the standard enthalpy of atomization. So looking at my information I've been given, I can see that the standard enthalpy of atomization of potassium is 90 kilojoules per mole. Then what I need to do is convert that potassium in its gaseous form into a potassium ion. That will be the standard enthalpy of ionization, which again, looking at the data I've been given, is plus 420 kilojoules per mole. I then need to think about my chlorine. So I've got half a chlorine molecule as a gas, which I'm going to change into a single chlorine atom as a gas. Now this is going to be the bond dissociation enthalpy. Now looking at the information I've been given, I've been told that the bond dissociation enthalpy of chlorine is plus 244. Now that would be the case if I was going from Cl2 as a gas to as a Cl atom as a gas. Now I haven't done it like that. I've got half a Cl2, so I'm going to need half of 244. So my bond dissociation enthalpy is going to equal 122 kilojoules per mole. I've then got to ionize that chlorine, not ionize, I'm then going to need the electron affinity of that chlorine. So this step is going to be my chlorine gas gaining an electron. Again, I forgot to put my electron up there. Sorry. There it goes. And I'm going to add my electron on here as well. So it's going to give me Cl minus as a gas. Now this is the value that I'm going to try and work out using my Haber cycle. Then my final step here is going to be taking my K plus as a gas and my Cl minus as a gas and combining them together to make the KCl as a solid. Why am I putting that there? So that is going to be my lattice enthalpy of potassium chloride. So that's going to be lattice enthalpy, and that is minus 706 kilojoules per mole. I've then got in my question that the standard enthalpy of formation of potassium chloride is minus 436. I'm going to put that up here. And then I can start putting my cycle together. So I've got all my numbers, I've got all my equations. These are my equations that are going to need to go on my cycle. If I just adjust this a little bit. So again, following my rules as before, I'll keep flicking you back up so you can see the data. Right at the bottom is going to be my final product, which in this case is going to be KCl as a solid. Then on the left hand side I'm going to have my standard enthalpy of formation. So I'm going to put that here, and that is going to be going from potassium as a solid plus a half Cl2 as a gas. My arrow is going to point down, and it's going to have a value of minus 436, which I just did in my question, that I just wrote in my question above. I'm then going to convert my potassium to a gas, and I also have my half Cl2 as a gas, which is going to be my enthalpy of atomization, which has a value of 90. I am then going to turn that potassium into a potassium ion as a gas. I'm going to remember to write my electron this time, and half Cl2 as a gas, which is going to be my enthalpy of ionization as a value of 420. I'm then going to take my half Cl. Now I know already this is going to be my long one, but I'm going to take my half Cl and I'm going to turn it into a Cl atom, gaseous atom. So putting on here, I've got my K plus still, I've got my electron still, and I've now got Cl on its own. And if you remember before, I worked out that because it is just one atom, I halved the bond dissociation energy to get 122. And then I'm going to go to the other side because it's an electron affinity. I know it's going to be a negative value, and I haven't got it yet, but I'm going to have to work out the electron affinity. So to go from K plus, well, to go from Cl to Cl minus, so I'm going to have K plus and Cl minus both as gases. That's the answer that I want. And then my final value for the lattice enthalpy is minus 706. So if I just take that back a little bit for you, I've got all my numbers on there. I've got minus 436, 90, 420, 122, minus 706. So I can work out the left hand side. I'm going to turn this arrow around to make my maths a little bit more fluid. So I've got 436 and 90 and 420 and 122. So the left hand side is going to equal 1068 kilojoules. And then my right hand side, I want to know what this is. So I've got 1068 minus 706 should tell me that the difference is 362 kilojoules per mole, and because it is an electron affinity and I know it's pointing downwards, it's going to be minus 362 kilojoules per mole, which is my final answer. I can double check it by checking the left hand side is equal to the right hand side.